Hello friends, today we will discuss about chemical properties of alcohols. As you know, the structure of alcohols can be represented here in the figure given, and in alkanes here carbon-carbon bond and carbon-hydrogen bonds are not polar. The carbon and oxygen and hydrogen bonds in alcohols are polar. Apart from this, the oxygen atom of the OH group, that is hydroxyl group, has two unshared pairs of electrons. The reaction of alcohols may be divided into the following three categories, that is, reactions involving the rupture of oxygen hydrogen bond, reactions involving unshared electrons of oxygen atom. Number 3, that is reactions involving rupture of the carbon oxygen bond. Here, reactions involving rupture of the oxygen hydrogen bond. Typical reactions in which hydrogen atom of the hydroxyl group, that is OH group, is involved are described here. First is reactions involving uh, reactions with active metals, that is acidic character of alcohols. As we know, alcohols react with active metals like sodium Na and potassium K to give alkoxide of the metal and liberating hydrogen gas. Here given reactions and its general reaction is given that 2ROH plus 2Na gives 2RO minus Na plus, that is sodium alkoxide plus H2 hydrogen gas. And here is an example given, that is 2C2H5OH, that is ethanol plus 2Na, that is sodium. On reaction it gives 2C2H5ONA, that is sodium ethoxide plus hydrogen gas. The hydrogen atom of the hydroxyl group, that is OH group of alcohols, is displaced by active metals in this reaction. This reaction shows that the hydrogen atom of the OH group in alcohols is acidic in nature. The acidic nature of alcohols is due to the polar character of oxygen hydrogen bond, OH bond. However, alcohols are weaker with uh, alcohols are weaker than water, and it can be explained by comparison of the acidic strength of alcohols with that of water. As we know, the alcohols, its formula is ROH, that is general formula, and we have, or that is we say structure, and another structure of water, that is HOH. Here in oxygen there is partially negative charge, and in hydrogen partially positive charge is present in both of the hydrogen, and here oxygen have also partial negative charge. As we know, in water the OH group is attached to hydrogen atom, while in alcohols OH group is attached to alkyl groups, that is bonded with alkyl groups. So alkyl groups are electron releasing groups. As we know, alkyls are electron releasing groups. It releases alkyl group releases electrons to oxygen, that is O, to form negative charge, that is electron density at oxygen atom increases. The presence of alkyl group in alcohol increases the electron density at the oxygen atom, due to which oxygen atom shows lesser tendency to withdraw electrons from hydrogen atom. That is the interaction between oxygen and hydrogen. That is interaction between oxygen and hydrogen becomes laser as the electrons withdrawn by from hydrogen by oxygen atom is laser. So this decreases the polarity of oxygen hydrogen bond and breaking of OH bond becomes difficult. So alcohols are weaker acids than water because as we know the definition of acid to release hydrogen atom in water. Another we have comparison of the acidic strengths of primary, secondary and tertiary alcohols. The presence of alkyl group in alcohols, that is R, makes the OH bond less polar due to the electron releasing tendency, that is positive I effect of the alkyl group. As we know in the previous comparison we also discussed about that. So the presence of the alkyl group in alcohols lower the acidic strength of alcohols, since such an effect increases in going from primary alcohol to tertiary alcohol. Here the number of R group, that is alkyl group, is more in tertiary alcohol. We have to know here that R group increases as electron releasing group increases, which means there is higher electron density on oxygen atom, due to which there is a lesser tendency of the breaking down of hydrogen with oxygen. The bond between oxygen and hydrogen breaks not easily. It becomes difficult in tertiary alcohol. Similarly, in secondary alcohol, as that of primary alcohols, we have two number of alkyl group, which is electron releasing group, which forms positive I effect, due to which it is difficult of breaking down of oxygen and hydrogen atom. And similarly, in uh, primary alcohol, there is only one R group, that is alkyl group, that is electron releasing group. It forms positive I effect, and here is the breaking down between oxygen and hydrogen bond is easier as that of tertiary alcohol and secondary alcohol. So here in this figure we have arrow showing that acidic strength decreases from primary to tertiary alcohol, as the acidic primary alcohol uh, strongest in tertiary alcohol strongest oxygen hydrogen bond is here. So it is more acidic than that of primary alcohol, that is tertiary alcohol is more acidic than primary alcohol. Primary secondary alcohol is also more acidic than primary alcohol, and uh, uh, secondary alcohol is less acidic than tertiary alcohol and more acidic than primary alcohol. We have another reactions, that is reactions with organic carboxylic acids. Here alcohols reacts with carboxylic acids, that is RCOOH, that is carboxylic acid, and here alcohols reacts in presence of concentrated sulfuric acid to form esters, whose formula is RCOOR. Here we have general formula that carboxylic acid on reaction with alcohol in presence of conc sulfuric acid, it forms ester and water. And another example we have given that ethanoic acid, that is acetic acid, reacts with ethanol, that is ethyl alcohol, in presence of conc sulfuric acid to form ethyl ethanoate, that is ester and ethyl acetate, and hydrogen chloride HCl. The esterification reaction is reversible reaction, and it is also shown in the picture. So the reaction should be carried out in the presence of dehydrating agent like conc sulfuric acid. Another we have reaction with acid anhydrides and acyl chlorides. Alcohols, when treated with an acyl chloride or acid anhydride in the presence of pyridine, that is catalyst, give esters. In this reaction, hydrogen atom of the OH group of alcohol is replaced by RCO group, and the reaction is called as acylation reaction. When acetic anhydride or acetyl chloride reacts, then it forms acylation reaction, acetylation reaction, acylation reaction, and acetylation reaction. Acetic anhydride and acetyl chloride forms acetylation reaction, and acyl group on replacement of OH hydrogen of OH group forms acylation reaction. That is, we have general formula here. CH3COCl, that is ethanoyl chloride, is acetyl chloride. On treatment with ethanol in presence of pyridine, it forms ethyl ethanoate, that is ethyl acetate, and hydrochloric acid. Another we have ethanoic anhydride, that is acetic anhydride, CH3COOCOCH3 plus plus C2H5OH, that is ethanol, in presence of pyridine forms ethyl ethanoate and ethanoic acid, acetic acid also. Here the reactions takes place in presence of pyridine, and if acetyl anhydride or acetyl chloride is acetic anhydride and or acetyl chloride is present, then reaction is called acetylation. And if acyl chloride, that is RCO group, acyl group is attached by replacing hydrogen atom, it forms, that is acylation reaction. The top one of the reaction given example is acylation reaction, and the bottom one is acetylation reaction. Another we have reaction with Grignard's reagent. Alcohols on treatment with Grignard's reagent give the corresponding hydrocarbons. ROH plus R dash MgX, it gives R dash H, that is hydrocarbon, plus MgOR and X, that is ROMgX. Here we have another example. Here C2H5OH, that is ethanol, on treatment with Grignard's reagent, that is ethyl magnesium bromide, that is A Grignard's reagent. It gives ethane, that is C2H6 and C2H5O MgBr. Thanks for watching this video. Please subscribe our channel. Press the bell icon for get more updates, and please share, comment on the section, and like the videos. Thanks for watching. Stay safe, stay healthy. Thanks.